Hi everyone, I'm Dr. Gauri Balachandar. I'm currently an assistant professor in the School of Biomedical Engineering at IIT BHU Varanasi. I joined bioengineering in 2012 after my BTech in biotechnology from PST Tech Coimbatore. So in 2012, when I joined, we were the first batch of students for bioengineering, and I graduated in 2018. So when I joined bioengineering first, it was a very unconventional program at that time in the institute and as well as in the country. So each of us had two supervisors from one from sciences and one from engineering. And apart from this, we also had a core set of courses that we had to do. So it was very diverse, and then we were trying to understand the basics of the science and as well as the engineering to qualify as a bioengineering student. So this experience was very varied in the beginning because we were still trying to adapt to completely different fields of research and learning. For example, I was a student between molecular MRDG, or right now it is called as DBGL, developmental genetics, and between material sciences. So I had to attend courses which were core cancer-based courses, completely molecular and cellular biology, and I also had to take courses on polymer science and technology. So initially, the experiences were a bit challenging to adapt to this. But as we kind of settled in, we started understanding what we needed to do and why this was happening. So each of our projects had one problem, and in a particular faculty of research. For example, I had a problem. I started out with a problem in cancer research, and the solution for us is more from the engineering side or from the materials engineering side. So we needed to understand the problem completely from the biology point of view, and then we need to learn the techniques from the materials side to apply it to solve the problem in biology. So when we reached a stage where we started on the research, that is when we started understanding how the different courses work and how the different types of, sitting just through the lab meets of different labs actually started helping in our own projects. So for us to realize this, it took a while. And then when we settled down, it was fairly easy to tackle these issues. And one of the best experiences that bioengineering gave us was the ability to innovate. We could solve the problems using interdisciplinary approaches. And if you see a lot, all of us had problems where we had to innovate the solution. So that was a very interesting research part that we took. And oftentimes we also found solutions not just in the engineering department that we were concerned with or in the sciences department that we were concerned with, but also from the other departments, simply through listening to their research work, listening to the lectures, and also attending seminars. So bioengineering gave us the ability to think far and beyond the conventional single discipline, and it made us innovate, and it also helped us look at solutions from different parts of or different faculties of research. So that means bioengineering was a major change in the way we were looking at problems and we were looking at solutions. Apart from the research, I would say it gave us a huge exposure to the diversity of people and the school of thoughts that a very traditional sciences discipline or a very traditional engineering discipline had. And we were able to pick the best of each. We were able to understand the pros and cons of each, which I would say is tremendously helping me in my academic journey as an independent PI. So I've just started. It has been 2+ years as an independent PI, although I am from the biomedical engineering department, which is more towards electronics, instrumentation, and a part of bioengineering. But I'm able to see, understand the students' perspectives and how to introduce them to a more interdisciplinary approaches. So that means bioengineering was very helpful for us to look at diverse things, look at solutions differently, think of problems differently. And the best part was we could innovate and we had the luxury to innovate. But the same thing can also be a challenge. So when we innovate, it is not readily accepted by everybody. So we had a bit of challenges in terms of trying to if I have to adopt an approach that is completely contradictory to what a traditional biologist would do, it takes a bit of effort to explain to them and to prove them how things work. So the innovation also brings with itself some challenges because you're challenging the traditional school of thoughts, and that also I would say was a great experience for each of us. As I mentioned earlier, I worked with Professor Annapurni Rangarajan from DBGL and Professor Kaushik Chatterjee from Biomaterials. And they taught molecular oncology and biomaterials courses, respectively. So each of these courses were very important for my own research and then very specifically to what I was trying to do exactly. Like so I was trying to make three-dimensional scaffolds using polymers for making models, 3D models in for making breast cancer metastasis. But apart from this project, what kind of also helped in the overall understanding where courses like transport phenomenon, or we had the course of biotransport phenomenon and biothermodynamics. The course was jointly handled by Professor Narendra Dikshit and Professor Ganapati Ayappa. So that course also, although we were very new to this course, I had a very basics of this course in my BTech Biotechnology. But this was a very not so very easy course, and it took a lot of learning to understand the concepts. But this course personally helped me in my academic journey because this is one of the greatest strengths I have as a faculty member in the current place. Because not many interdisciplinary faculty can actually teach a transport phenomenon course. It is usually handled by pure chemical engineers or mechanical engineers. But me being exposed to this course, and I was a TA for this course, and now it has helped me take this course in my department without having my department to rely on other department faculty to handle this course. So that way, in my personal academic journey, the transport phenomenon course, although at that point of time was very tough and very challenging, has helped me as an independent faculty. And now that I understand both biology and engineering, it also helps me give a more perspectives of these transport phenomenon for biological and biomedical applications. So that was very important course. So apart from this, we have also courses on basics of life sciences, ecology. These were also very important, a little bit of biomechanics. So I think each of these courses, although I wouldn't say we go into the depths of all of these, it gives you kind of the basics as to look at things from a different perspective. For example, as a biologist, we think of a skeletal system as a very inert part of the body. But when you do biomechanics, we tend to appreciate how much how much evolution has brought us where we are in terms of balance, acts of balancing, acts of walking, and so on and so forth. So, although we don't understand the physics as such, we tend to look at it from a very non very innate part of our body. The physics that we do in an everyday life is amazing. So that way, I think the course gives you an appreciation. Most of the courses help you understand and appreciate and open up several different perspectives. And for me, the transport phenomenon course was very helpful. And yeah, I'd be very happy, thankful to Professor Suresh, who insisted on us taking the course, and Professor Dikshit for handling the course. Initially, in the BE department was very challenging because we didn't have a parent department at that point of time. So we used to juggle between different departments, and then yes, attend the BE meetings or the BE seminars separately. Over time, it taught us again. One is bioengineering was associated with more interdisciplinary research and faculty. The other part of the BE training was also to bring together people from different parts of the institute, which was otherwise, I would say, very impossible. It would be very rare to spot an engineer in the biological sciences building and the vice versa. So that way, we also started appreciating not just the science, but also the people and the amount of effort that goes into running such programs. Because interdisciplinary research is not easy to the student as well as the faculty and the chairs who are heading this whole thing. So the time in BE or bioengineering kind of helped us see all this and to appreciate the effort that goes into running such a program, and we always never fail to celebrate its students. So we were very happy to be a part of it and spend time. So one piece of advice I would give for bioengineering or anybody who aspires to do PhD in bioengineering at ISC Bangalore or any other place is that there is some amount of learning involved. So you don't, although if you've done research either as a biologist or as an engineer, it doesn't guarantee that you jumpstart on research in bioengineering. So I think you have to give the time to learn, so unlearn and relearn a lot of new concepts, to be very open in your ideas. Most of at least me and my batchmates, the solutions didn't happen reading a paper. The solutions happened when we discussed over coffees, when we spoke about, when we voiced out the problems that we had. So, as a bioengineer, true bioengineer, you should be ready to explain your problem and take suggestions or discuss the problem more with different people, and you might be able to find solutions. So it does take some amount of patience to first um, learn, explore the problem, and innovation doesn't happen in a day. So B gives excellent chances to innovate, but that takes a bit of time, and you need to have a very hardworking and as well as a patient process to be able to see the light at the end of the tunnel. So, as a bioengineering student myself, I would say the results are not going to flow in from day one. For example, if I were a complete biologist, if I knew Western blots, I could straight away go start doing some of these experiments. Or if I were just to do materials, if I had a polymer, I could just jumpstart on characterization or making more different combinations of the polymer for specific purposes. But as a bioengineer, it's not just that. You need to be able to do both and as well as address the problem accurately. So this needs a lot of learning, patience, and uh, discussions, and that will help you do very well.